This is Mr. Martin. These are the video notes for Geometry Honors Section 2.2. This video is going to be on complementary and supplementary. These are two very important concepts that we'll use almost the entire school year. So make sure you understand them. If you have any questions, make sure you ask me in class. So also make sure you can write the converses of all of these, so you may want to include those on your theorem sheets. And again, if you have questions about the converses and if you stated them correctly, make sure you ask me, or when you share it with me on Google Docs, just put a little note there to check the converses, and I will be happy to do that for you. So complementary, two different versions of the definition. The first one is if two angles, notice the word two, because it's only two angles. Because you could have three angles that add up to 90, but they would not be considered complementary because it's more than two. So if two angles are complementary, then their sum is 90 degrees. Or the other version, if two angles are complementary, then their sum is a right angle. So again, 2. Alright, now keep in mind that it can be two angles that are sharing a vertex like this. So we have a right angle. So here's angle 1 and angle 2. They would be complementary. And we would write angle 1 is complementary to angle 2. Or I could have an angle over here, angle 3, and another angle over here, angle 4. And if the sum of those two angles was 90, we would also say that they were complementary. So they can share a vertex, or they don't have to share a vertex. So that's basically complementary. And then supplementary, again, if two angles are supplementary, then their sum is 180 degrees, or if two angles are supplementary, then their sum is a straight angle. So, and as you get more experience with two-column proofs, you'll know which of these to use in the proof, which one's appropriate. And again, put these on your theorem sheets. Make sure you get the converses on there as well. So let's take a look at some examples here. The first one's pretty straightforward. If the measure of an angle is x degrees, we want to find its complement and its supplement. So I'm going to draw two pictures here. And again, it doesn't necessarily have to look like this because the angles could be separate. But if I have picture like this, and I know that the measure of this angle is x, we want to find the measure of this angle. So the total angle is 90. We've already used x degrees of that, so the other angle would be 90 minus x. Okay, so we can see that x and 90 minus x, those are going to be complements. And then again, I'm going to look at two supplementary angles that share a vertex. They don't necessarily have to. So if this angle is x, then this would be what's left of the 180. That would be 180 minus x. So again, the x and 180 minus x are supplementary. So 90 minus x is the complement, and 180 minus x is the supplement. Alright, moving on. Just a couple of proofs. If it's going to take more than 2 steps, I'm going to go ahead and do a two-column proof. But if I can use one reason to prove our conclusion, I'm just going to write that one reason. So we're given that angle PQR is a right angle, so I'm going to go ahead and put my right angle marker in there, and we want to prove that angle 1 is complementary to angle 2. Well, we can use the converse of the definition. So we can use right away to prove that. So if the sum of two angles is a right angle. Notice I used the form of the definition that has right angle so that it matches with the given. Then they are complementary. And if you want to see if you can do these on your own, feel free to pause the video and then restart it just to check your answers. Alright, moving on to the next one. Same picture, almost the same problem, except now instead of being given that it's a right angle, we're given that it's 90 degrees. So we're going to use the form that has 90 degrees in it. So if the sum of two angles is 90 degrees, and again, make sure you include the 2, then they are complementary. Okay, again, we could do a two-column proof, since really we can state our final conclusion based on the given information. I'm going to forego that for now. Alright, same picture as before. Now we've got angle 1 is complementary to angle 2, and we want to prove that PQ is perpendicular to QR. So I'm going to set up my two columns here. Statements, reasons. I'm going to go ahead and put in my given. So I've got angle 1 is complementary to angle 2, given. And I know from my definition that if two angles are complementary, then their sum is a right angle. And I'm going to need that because in order to prove that two lines are perpendicular, I need to know that they form a right angle. So I need a right angle first. So angle PQR is a right angle if two angles are complementary, don't forget the word two, then their sum is a right angle. And now that we have that two lines form this right angle, we can say that the two lines are perpendicular. So PQ is perpendicular to line QR if lines intersect at a right angle, then they are perpendicular. Okay, so again, notice how this works. Here's my keyword right angle, and it matches with a step that I already had, right angle, so it matches back up there. And then perpendicular, that's my keyword in my conclusion, matches with my statement of the same number. So it's got to match up like that. Alright, and it also matches up here. Here's complementary, so this matches back up here to complementary. So everything's got to match. The hypothesis of the statement matches with something previously done in the proof, either a step or multiple steps, and the conclusion matches with the same step. Alright, moving on. Angle 1 is supplementary to angle 2. So let's see, we've got a typo here, so we'll just make this a 1, and we'll make this a 2. We want to prove that LAT is a straight angle. Again, we could do a two-column proof, but it's really not necessary for this case since I can prove my conclusion based on the given. So if two angles are supplementary, then their sum is a straight angle. Alright, moving on. The measure of one of two complementary angles is 6 greater than 3 times the other. Define your angles and find each measure. So we've got complementary angles, so I'm going to let one of the angles be x. Alright, and the other one is 6 greater than 3 times the other. So this one's got to be 3x plus 6. 6 greater is plus 6, and then 3 times the other. And since they're complementary, I know that they have to add up to 90. So when you're defining your variables, if you want to define them, in graphic form, that's okay as well. Otherwise, you're going to do something like let x equal the angle, and then let 3x plus 6 equal the complement. Okay, so you'll do something like this. So either one of these is fine. Since they're complementary, I know that their sum is going to be 90, so then I can add them up. X plus 3x plus 6 is equal to 90, and then we'll go ahead and solve this for x. So I have 4x is equal to 84, which means x is equal to 21. Find the measure, define your angles, and find the measure of each. Okay, so the angle is going to be 21 degrees, and the complement is going to be 90 minus 21 degrees, which is going to be 69 degrees. So another important point here, make sure that you tell me what your numbers are. So I want you to label your answers. Don't just put 21 and 69. Show me that you understand that the angle, the original angle, however you want to write it, is 21 and that the complement is 69. If you just have some numbers floating around on the page, chances are I'm going to deduct points for not being clear. Alright, again, if you had any questions, make sure you ask, and we'll see you in class.